Well, alright now. Hopefully you remember from last time what translation and reflection means. Translation, if you forgot, means you're just sliding something. So translation literally just means boom, move, slide. And a reflection is a mirror image. You're flipping it over in some way. So, when we're talking about translation, there's a certain way that's going to be written. It's a slide. We're going to write this in what's called vector format. Okay, I can't keep doing that anymore. Basically, whenever we do a translation, it's going to be moved by what's called vector format, which is denoted by these brackets and X and Y. And all that means is move it in X direction, then the Y direction. So it's almost just like a point. You walk and then you climb the ladder. So, given a graph, and basically most of this, well, for translation, all of this is going to happen in a graph. I guess I could make you do it if I gave you a ruler and said move this, 6 inches by 8 inches or something like that, but that seems a little bit overkill. Alright, so if I have point A and I say translate A by bracket 3, -1. I said all that literally means is count over 3. 1, 2, 3, down 1. And we have A prime. So translations are in general the easiest of all of the transformations, because all you're doing is moving it, and all you have to know how to do for that is to count. I could also give you a shape to move. Bloop, bloop, bloop. Hopefully when you're doing your notes, you're making the sounds too. If not, you're doing it wrong. Alright, so I can say translate the triangle by -4, 3. So what that means is you take this and you go 1, 2, 3, 4. 1, 2, 3. Now, you could just do that for each and every point, and you're fine. Another way you could do this, because one of those properties of transformations, what is it? That it preserves distance. This goes up 1 over 1. So you could actually just go up 1 over 1. And this goes left 1 up 2, so you can go left 1 up 2. So there's more than one way to do the translation. So I'm just going to put the prime there because that's the new one. And that's literally all you're ever going to have to do with translation for the most part. I could ask you one last kind of question, and it'll say something like, how far away did each point move from the original spot? And you have two choices: Pythagorean theorem or the distance formula. I prefer Pythagorean theorem. I just think it's easier. So just in case you've forgotten, that's a squared plus b squared equals c squared. And the distance formula, which you should have just done a quiz on not too long ago, is distance equals the square root of x2 minus x1 squared plus y2 minus y1 squared. So if you're going to use the Pythagorean theorem, literally you just take these two numbers as a and b. And you don't even have to worry about positive or negatives. So I would just do 4 squared plus 3 squared equals c squared. 16 plus 9 equals c squared. Then you get 25 equals c squared. Square root both sides and you get 5 equals c. So basically, if you measured each point on a ruler, if this was all the scale, each point would be exactly 5 units away. That's all for translation. Like I said, it's generally the simplest one. It's just moving things and knowing what's going on. Reflections. Remember, it's a mirror image. Mirror image. Alright. And so, something that I like to say is that a reflection changes direction. What I mean by that, well, I'll get into that more. Just, you know, if you have a shape like this, right? This is pointing to the left, the cap is, but when you reflect it, it's suddenly pointing to the right. So you're changing the direction things are happening with. There's some formulas you can know. You don't have to use these formulas. In fact, I normally do not. I don't know what I'm writing there. But some of you are formula people, so I'm going to write the formulas here. Reflect over the x-axis. xy turns into x negative y. So basically you just take whatever the points are, and you put a negative in front of that y value there. If you reflect over the y-axis, you get xy turns into negative x, y. So if you're going that way, just putting a negative in front of the x value. You can reflect over the origin, which if you don't remember is the very middle point. That's the origin right there. xy becomes negative x, negative y. So you basically put a negative in front of both of them. And these are the two hardest ones. And these are the two that if anybody memorizes formulas, if they hate formulas, these are the ones that they memorize. Over y equals x. And we'll talk about that in a minute. xy turns into yx. So when you're reflecting over the line y equals x, you literally just flip the 2 points. And then lastly, you can reflect over the line y equals negative x, which is pretty similar to what we just did. You're going to flip the 2 points, but they're both going to have negatives in front. Okay. So if you're a formula person, this will get you through a lot of the reflecting stuff. So I'm just going to put this here. Let's not waste paper. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Bloop, bloop, bloop. Bloop, 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 bloop. Doop, doop, bloop. Bloop, bloop, bloop. Alright, so reflecting. Let's say I have a triangle that I call A, B, C. So, if I want to reflect over the x-axis, what I could do is look at each point, right, and use a formula. This is 4, 1, 2, 3, 4. This is 3, 1, 2. And this is 1, 2, 3, 4, 5, 6, 7. 1, 2, 3. Right? So I could just take each of those y coordinates and put a negative. So it would be 3, negative 2 instead. 4, negative 4. Barely, I can't count. And then 7, negative 3. And then you're done. And like I said, it should look like it's been flipped, and my lines are obviously not straight. B prime, A prime, C prime. So if you're a formula person, that's all you have to do. I generally don't do that when I'm reflecting on a coordinate plane. I like to just count. What I'll just do is find the x-axis and go 1, 2, 1, 2. 1, 2, 3, 4, 1, 2, 3, 4. 1, 2, 3, 1, 2, 3. And I just usually just draw it and count it out. So I think that's a little bit easier to do. So, same thing you can do with if I wanted to reflect over the y-axis. You could just change the x-coordinate, but like I said, I like to go 1, 2, 3, 1, 2, 3. That's B prime. This is 7, 1, 2, 3, 4, 5, 6, 7. C prime. This is over 4, so I just count over 4. A prime. And hopefully, the reason I'm labeling all the points all these times so that you can see that it's flipped around. So with reflecting, that's all you have to do for y-axis and x-axis. Lastly, origin. Man, I don't know what color I want. So for the origin, really you're reflecting it over both axes is all it's really asking you to do. So usually what I do is count down 2 over 3, down 2 over 3. Down 3 over 7, down 3 over 7. C prime, B prime, and then down 4 over 4, down 1, 2, 3, 4, over 1, 2, 3, 4. A prime. So reflecting over the origin is literally what we just did, but both. So it's x-axis, y-axis, or it's y-axis, x-axis. So it's basically the combination of both. And really, I should have the proper amount of tick marks there, just to remind you that these are different transformations. Alright, I'm going to turn the page and then do a second part because this is already 15 minutes long, and that's about the limit.